start with glycolysis. So let's dive in. What is glycolysis? Glycolysis is the conversion of glucose to pyruvate. And in glycolysis, our end product is pyruvate. So if they ask you, what is glycolysis? Glycolysis is the conversion of glucose, which is a 6-carbon molecule, to pyruvate, which is a 3-carbon molecule. And in this process of glycolysis, one glucose yields to pyruvate. Don't worry, I'm going to show you this. One glucose yield to pyruvate. Now, so let's start. In glycolysis, what is the first state? The first state is we convert glucose to glucose-6-phosphate by an enzyme known as hexokinase. If it's in the muscle, we call it hexokinase. Stimulates the formation of glucose to glucose-6-phosphate. If it's in the liver, we call it glucokinase. Stimulate the formation of glucose to glucose-6-phosphate. But first, when you eat carbohydrates, it results to simple sugar. An example of sugar is glucose. So these simple sugar are in our intestine, the small intestine. So that's also called a microvilli, which is made up of epithelial tissues. We absorb these nutrients into the bloodstream. As this glucose is in the bloodstream, it cannot be taken into the cell directly. The only thing that can be done is through another process. So glucose can only be transported through the cell, inside the cell. So glucose is always in the blood. So whenever glucose is transported into the cell, it is known as what? GLUT2 transporters or GLUT transporters. So what do? They transfer this glucose from the bloodstream to the cell. So example is what? The GLUT2 transporters. And glucose is like a more neutral and balanced molecule. So we are converting glucose to glucose-6-phosphate. Some people start asking me, why are we converting glucose to glucose-6-phosphate? We are converting glucose to glucose-6-phosphate because when we add phosphate to this glucose molecule, it will now become negatively charged. It will now become polarized. This polarity will now make it impossible for this to leave the GLUT2 transporters. Glucose are bidirectional, so they can move in and they can move out. But when they move in, the only way we can prevent them from moving out is by adding phosphate group, which is usually done by the hexokinase if this process is occurring in the muscle, or glucokinase if this process is occurring in the liver. So at the process, we now take ATP and we now convert them towards ADP. So ATP is adenosine triphosphate and ADP is adenosine diphosphate. So ATP means we have 3 molecules of phosphate group. ADP means we have 2 molecules of phosphate group. So when this ATP will come and donate its phosphate group, one of its phosphate group, to the glucose to form glucose-6-phosphate. So instead of it becoming 3, which is tri, we now have 2, which is what? Di. So that's why we convert ATP towards ADP. And through this process, we now convert glucose towards glucose-6-phosphate. Remember, we are converting glucose to glucose-6-phosphate because we are polarizing it in order to form a substrate that will go and produce what? Pyruvate. Remember, our main aim is to produce pyruvate, and glycolysis is the process by which converts glucose towards pyruvate. Now from here, we now convert this glucose-6-phosphate towards fructose-6-phosphate, and it is done by enzyme known as phosphohexoisomerase. So phosphohexoisomerase stimulates the conversion of glucose-6-phosphate to fructose-6-phosphate. If they ask you which enzyme converts glucose to glucose 6-phosphate. If in the muscle, choose hexokinase. If in the liver, choose glucokinase. But if they did not specify, you see hexokinase or glucokinase, just choose one of them. Another question is, which enzyme converts glucose 6-phosphate to fructose 6-phosphate? Is phosphohexoisomerase. Convert what? Fructose 6-phosphate to glucose 6-phosphate to fructose 6-phosphate. And another enzyme known as the PFK type 1. So this PFK type 1 is also called the phosphofructose kinase type 1. So the phosphofructose kinase type 1 converts fructose 6-phosphate to fructose 1,6-bisphosphate by doing what? Taking ATP molecule and converting them to what? ADP molecule. Just observe something. So what you have to observe is, in the conversion of fructose 6-phosphate to fructose 1,6-bisphosphate, an enzyme called phosphofructose kinase type 1 is doing that. And I want you to observe something. Now we have the word kinase. We now have the word kinase. We now also have the word kinase. Now I want to bring to your focus or to your understanding that kinase, their function is just to transfer phosphate from one group to another. Example of what I said is, we have the hexokinase and we have the glucokinase. What are they doing? They are transferring phosphate group from the ATP molecule to glucose to now form what? Glucose 6-phosphate, and converting this ATP towards ADP. The same thing, fructose 6-phosphate is stimulated by enzyme known as phosphofructose kinase type 1. And what is the kinase doing? It's taking ATP molecule and is converting fructose 6-phosphate towards fructose 1,6-bisphosphate. And during the process by which this is done, first is, I want you to also understand something. What is fructose 1,6-bisphosphate? So why didn't we call it fructose 1,6-biphosphate, but we call it bis? We call this term bis because they are far away from each other. So bis means they are far away from each other, while bi means they are closer to each other. So remember, glucose has 6 molecules, 1, 2, 3, 4, 5, 6. So the bis means we added the phosphate group to the first molecule and to the 6th molecule. So for this reason, they are far away from each other. That's why you call it what? Bis. Now we now have what? Fructose 1,6. So the word fructose is the name of the group. 1,6 means the phosphates attached at the 1 and at the 6, because this is 1, 2, 3, 4, 5, 6. So it's attached at the 1 and the 6. We now have what? Bis, because they are what? Far from each other. We now have phosphates because they are what? Phosphate group. Don't forget that. Now we